Welcome back. Hey, what's been going on here? I've been scribbling again. Can you see what this one's about? It says something about expansions. We didn't tell you before, but when you do this multiplication here by FOIL firsts and lasts, inners and outers, that's 1 by this one, neg 2x, 2 by x is plus 2x, 2 by neg 2, getting sick of this? It's x squared. Take 2x plus 2x would come to no x's. X squared take 4. That process is called expanding brackets. So we have a new name here in algebra land for that multiplying out, simplifying expressions that we did before. And have a look at the other word in this part. It's expansions with patterns. So, can you see the patterns here? Let's do another one. This one here, let's do that. X by x is x squared. X by 1 is 1x. 1 by x. Another 1x. 1 by 1 is 1. So this is x squared plus 2x plus 1. Starting to look different. Let's come over to do this one over here. X by x is x squared. X by neg 3, neg 3x plus 3x times in there. 3 times neg 3, neg 9. This one, wipe out. Neg 3x plus 3x is no x. Hey, there's some patterns emerging here. Well, I told you, this is part 3, expansions with patterns. Now let's come down to this one. X by x is x squared. X by neg 4 is neg 4x. 4 by x is 4x. 4 by neg 4 is neg 16. Uh-oh, another wipeout. Neg 4x plus 4x is no x's. So it's x squared take 16. So it looks like sometimes you don't get the middle x term, you get wipeout. Can you see what the bracket must look like to get that? Okay, we'll come back and summarise that in a minute. What's the other type? The other type is, let's look at it again, x by x is x squared, x by 4, 4x, 4 by x. It's another one. There seems to be a doubling up going on here, mate. So what do we get? We're getting x squared, not wipe out, but double the term. In the middle there, there's 2 lots of the same thing. I think it happened up here too, didn't it? What sort of pair of brackets, what expansion gives rise to that doubling term? Let's look at this one. Oh, what's a square? I think by now we know a square is when a number is times by itself. So remember, if x is a number, then x plus 5 is a number, just a number 5 units bigger than x. So this is what it means here. So here we go, x by x is x squared. X by 5 plus 5x. 5 by x, another 5x. Yes, done it again. It's done it to us again. It's doubled up, x squared plus 10x plus 25. So we've done lots of expanding. You can see why it's called expanding. It's writing out the full meaning, or expanding the meaning of the 2 brackets times together, which we did in the last presentation. So can you somehow summarise what's going on here? When do you get wipeout? Let's summarise it like this. Can you follow this? When you have 2 terms, let's call the first one A and the second one B, and we times it by identical bracket, but with a minus between them. Because let's just check that out now. A by A would give A squared. A by neg B give neg AB. B by A would give plus BA. That's why it wipes out. Neg B squared. Because in the 2 brackets here we have opposite signs. Exactly the same terms, but with opposite signs between them. So you get that middle term wiping out. You just get a pattern which is the first term. The first term is squared because it's the same in the two brackets, minus the second term squared. No middle term. Okay, you might study that one. Okay, what's the other pattern up here? Well, I think it was when you had a number squared like that. So that meant the two brackets were identical. And they sort of reinforce each other, don't they? Because you get a by a, which is a squared. Then this one is plus ab. And you'll get the same thing here, plus ba. Are they the same? Are they the same? A times b, is that equal to b times a? Let's just check it out over here. If we had two numbers, 2 times 3 is 6, yes, and if we did it the other way, 3 times 2 is 6. Well, I don't know whether you've ever heard of the word for that, when you can do the operation in either order and it doesn't change the meaning. It's called the fact that the multiplication can be done in either order with the same value is the commutative rule. Doesn't matter which way around you do it. So that's what we've got happening here. A from one bracket times b in the other, and then b from that bracket times a in the other. It will be the same thing. And then we've got b by b is b squared. Remember, a number of times itself is a square. So we've actually doubled up the middle term here in this pattern. Okay, so there are two actual patterns that occur in these expansions. This one you'd say is what? The first term has been squared. All of that's been squared. And then you've got plus 2 times the product of the terms, a and b, the first and the second, plus then the second term is squared. So they have something in common. They have quite a bit in common, really, because one is this one over here. Is the first and second term are the same, a and b in both, with the opposite signs. And then over here, a and b are the same in both and the same sign. So just a repeat, a squaring of that bracket. So you can see here quite clearly that there are patterns. I want you just to think about that for the minute. Oh, I've mixed some up for you. So can you spot the patterns here? Remember what we said, when we have a bracket with 2 terms in it, and then the other bracket, same 2 terms, but the opposite sign, it comes to a squared take b squared. This sort of expansion is sometimes called the difference of 2 squares. And you can see why. Because we've got the term in the middle disappearing, we end up with just the first term squared and minus the second term squared. And the other type is, of course, when the brackets are identical. So there's 2 ways. This comes to a squared plus double that middle term plus b squared. But you might also think here, what if there was a negative between them, like that? It would equal a squared, and this middle term would be negative 2ab. They'd both be negative. They still collect them up though, and the square down the end would still be plus b squared. So the negative has a slight variation there. This is called the perfect square form. Perfect square. Because both brackets are just like each other. They're perfectly the same. Here is your little exercise. Here is a bundle. I've made up this bundle for you. Now, I'll tell you, each one of them is one of the 2 pattern types. What I want you to do down over this side, on the left-hand side, I want you to write down all the ones that are like this, a difference of 2 squares. And over on the right-hand side over here, I want you to write down all the ones that are perfect squares. and make up a list. So do that on a piece of paper on your computer. Make up a list there of, on the left-hand side, all those that are of the pattern of the difference of two squares. That is, the same two terms in the brackets with opposite sign. Then on the right-hand side, list all those from this batch here that are perfect square types. Okay, so I'd like you to pause the presentation now, because you have to copy each of these expressions down somewhere on your computer on a piece of paper and make up your two sides. One side is difference of two squares, the other side are the perfect squares. Okay, so pause the presentation now. Right, I want to see if you got it right. Did you get this bundle here? There they all are. How did you go? All right, well, what we need to do now is to see if we can do the expansion more quickly. We don't want to do every term by every other term, or the FOIL method, first, outers, inners, last. We don't want to go through that if we don't have to. I think we've seen that these over on this side follow a certain pattern. A plus B by A take B. We might just come across here a bit further, get rid of that, and come up here and just put it over here. I think might be easier. A plus B by A take B. Without multiplying it out now, we have shown through doing this multiplication that you always get the middle terms wiping out. One is a positive AB and the other is a neg AB. So can we in these problems go straight to this? And over here, where we see the two brackets are identical, can we use what we did just up there, realising that you're always going to get the first term, and the next one is going to be double of the two terms multiplied together, the A and the B, because they're the same in both brackets. So you're going to get two lots of that product, plus then on the end B squared. So what I'd like you to do is to try to expand these expressions in the quick way, using the pattern, which is the difference of two squares, sometimes called dots like that, difference of two squares, and the perfect square over here. So if you recognise it, then you could actually use that now that we've proven it for the general case, and we could use that. So I'd like you to pause the presentation now and have a go at those four difference of two squares, and those four over on the right, the perfect squares. Right, coming back now, watch the answers here and mark your work. So let's see, x plus 2 by x take 2, it'll come to the first one squared minus the second one squared, which you could write as x squared take 16. Okay, let's look at the next one. First term plus second, first term minus second. That follows the pattern. We know what's going to happen without doing the expansion. So first one squared minus the second one squared, which is x squared take 1. Let's do it again then down here, doing all the difference of two squares. First term minus second, first term plus second. Does it matter that the minus is in the front? No, it won't. You will still get the opposite sign for that middle term, and you'll get wipeout of those terms. So it's going to be the first term squared minus the second term squared, which is a squared take 25. So it's quite clever using patterns here to do those that are difference of two squares. Let's come down and just have a bit of room down here for this one. This is x plus 7, x take 7, so it's going to be x squared minus 7 squared, which is going to be x squared minus 49. Okay, so mark your work and see what you think. You can pause and rewind the presentation, come up and down all you like here if you like, so you can do that. Let's have a look at the other side, the perfect square type. Can you see that the pattern is different first term plus second term, and the same first term and the same second term. It is a perfect square. So what's it come to? First term squared. So I've got to square all of 5x. Be careful there. Don't leave out the 5. Plus now twice the product. It's 2 times the first one times the second plus 2 squared. That's a squared plus 2ab plus b squared. Can you see the pattern? And do you know why this double term occurs? Because you get that multiplication from both brackets. So here it's 25x squared plus here 2 times 5 is 10. That's 10x, and double it again is 20x plus 4. Gee, that saves a lot of time, doesn't it? If you get lost, you could always go back and multiply these all out. We could do it by FOIL, first and last, inners and outers, every term by every other term. But it's nice to use a pattern now that we see it's always going to happen. Okay, let's do this one. It's the first term squared plus 2 times the product of the terms, 2 times 3 times x, or x times 3. Does it matter which order we put that in? Do you remember? The order in multiplication doesn't matter. It doesn't matter whether you have 2 times 3 or 3 times 2 or 2 times x, x times 2, because multiplication is, remember the word, commutative from back before. You might like to go back with the presentation and have a look at that word. Let's go on here, and the second term squared is 3 squared. So here we have x squared plus 6x plus 9. Alright, are you getting the hang of it? Let's go down to the next one. Is this a perfect square? Oh yes it is. It's used a square notation. That's even more obvious. I'm going to write out what that notation of a square means. It means, of course, the numbers multiply by itself. And so that's what I've done. Multiply that number by itself. So what's the rule? What's the pattern? It's the first term squared plus 2 times the product plus the second term squared. So that becomes x squared plus 10x plus 25. Alright, can you see what's going on? But I reckon just as importantly, do you know why it's going on? Because of those terms doubling up, and we're getting 2 lots of that middle product there. Go back and do it the long way and just check it out if you wish. Shall we do this without writing it all out? It's a perfect square, so it's the first one squared plus twice the product, so it's 2 times, oh look out, neg 2 times x. Don't forget, the second term here is really neg 2, and then plus that second term, neg 2, all squared. So it's x squared. Now 2 times neg 2x is neg 4x. The middle term here would have been negative, and we had 2 of them. Neg 2 squared here, and negative times a negative is a positive. Now for that one, I think we should check it, just to see what's going on there with this negative business. I think we should check that, do it the long way. Alright, this one by this, x by x, x squared, there's the next one. X times neg 2 is neg 2x. And do it in here now, neg 2, oh, there's another neg 2x. And then neg 2 by neg 2 plus 4. So can you see why it works? The middle product terms are identical because the brackets are identical. And so we get 2 of the dudes. And that's what this is saying up here. 2 lots of that middle product, neg 2 times x. This is a powerful tool later on in mathematics if you can spot when this is happening. Alright, well I hope you've got the idea of those 2 patterns, because this is coming to the end. You've really built up a lot of skills now, and the next presentation is about how we can use it. But let's go down and do some exercises perhaps now. And I've got some here. I don't know, we've got I think 12 of them here. 12 of these, and can you see, I've been kind to you, these are all difference of 2 squares. So what I'd like you to do now is to spot that and see if you can go through and use the pattern method to quickly write down what the expansion of these are. Okay, so pause the presentation now and have a go, and I'll come back and do them all with you. Alright, here we are. Here we are. There's a difference two squares. There's the first one squared minus the second one squared. Can we go straight to it? Shall we go across the page? First term squared minus second term squared. Hey, that's the same. What am I getting at? Well, it really doesn't matter. Those two signs, which one comes first, you'll still get wipe out of that middle product. Want to check it out? Multiply all the terms out. What about this one here? First term squared is 4 minus second term squared is x squared. So whatever's in the front of the bracket has to be the first squared. You can check it by multiplying it out there. So here, first term squared minus 7 squared. You might have to pause for that one. How's your times tables there, mate? 49. And this one, first term squared minus 8 squared. How's your times tables? 64 for that one. Can you see the pattern? First term squared minus second term squared. So it's d squared, take 25. Remember, you can pause the presentation any time and mark the work and check it out, make sure these are right. Well, here we are, first term squared minus second term squared, which is 4 take x squared. Whatever's in the front of the bracket has to be the first squared. Check it out. You can always check it out by timesings, okay, by the multiplication or expansion of these brackets. Here again, first term squared is 1, take second term squared is x squared. Same again, first term squared is 16, 4 squared, take d squared. Can you see what's happening there? Okay, let's have a look at the last ones now. Bit different here. We've got to square the first one, so let's just check that out and do that carefully. That's 2x all squared. Take 1 squared, which is just 1. 2x all squared is 4x squared. Take 1. And over here now, first term squared is 3x all squared minus second term squared, 2 squared. When you square 3x, it's 3x times 3x, which would be 9x squared. Remember your earlier work in working with x, just as a number. So here, first term squared is 3 squared, minus, got to square all of the second term, which is 4a. So it's 9 take 4a times 4a, 4 by 4 is 16a squared. Were you good enough to get them all right? Some hard ones in there. So go back, rewind the presentation, check your answers. And now I'm going to go on for your final exercise in seeing if you can work with x as a number. And here we have some. Have some little dudes here. What do you notice? These are all perfect squares. Perfect squares. So their pattern is different, isn't it? It's the first term squared plus twice the product of the two terms plus the second term squared. Alright, what I'd like you to do is to pause the presentation and have a go at these 12. Now, you might have to rewind the presentation to go back and look at that pattern for the perfect squares, because they're a bit harder to think of. So you might do that now. Anyway, when you've done all that, pause it and have a go, and I'll come back and go through it with you. Here we are back again. Remember the pattern for a perfect square. It's a first term squared plus 2 times twice the product of these. Usually put the number in front of x, not at the back, plus the second term squared. So here we go, x squared plus 10x plus 25 would be the full expansion. And the next one now, first term squared plus 2 times the product of these two, x times 4, we usually put the number in front, 4x, plus second term squared is 16. So this is x squared plus 8x plus 16. What about the next one? Can we see the pattern? First term squared plus 2 times the product of 7 and x, and second term squared, 49. So it's x squared plus 14x plus 49. I'll do the one over here, slightly different number in front. They will still behave just like numbers equally, so it's 5 squared plus 2 times 5x. Remember, twice the product of the two, plus the second term squared. So it's 25 plus 10x plus x squared. Are you seeing it? How did you go? Mark your work along the way and see if you got any wrong. Well, we think you're going to get them all right, so the wrong one's going to stand out, aren't they? So first term squared, and this is twice the product, but the product here is neg 3 and x, so it's neg 3x, so I've got to be careful here, plus 9, so this will actually be a total of neg 6x. Both the middle products would have been neg 3x, making a total of neg 6x. Let's look at this one. X squared plus twice the product, but the product here is negative. Neg 2 by x would have been the middle two products. Both of them would have been neg 2x. Plus the second one squared, which is 4. So it's x squared, take 4x plus 4. Notice that always the number down the end, even when it's a negative between the brackets, is a positive. Can you think for a minute why that might be so? Well, of course, let's just do it here. Let's remind ourselves of that one. That n term is formed by these two being times. And even though that's a negative, it's got a mate which is a negative, and a negative times a negative is positive. So in a bracket where you have a negative, in there, the only term that's affected is the middle product term. First term squared plus twice the product. The product is neg 8 by y. So it's 2 lots of neg 8y plus 64, second term squared. So it's y squared, take 16y plus 64. You don't actually have to put this line in if you're good enough to leave it out. Can we try one leaving that middle line out? First term squared. Now twice the product is 5 times neg x. That's neg 5x. Double it, neg 10x. Are you good enough to do that much in your head? Could be powerful being able to do it that fast. And then the second term squared would be positive x squared. Okay. How are you going with that stuff now? Right, let's have a look over here. Got a 3x there, so it's the first term squared plus twice the product. Now what's the product? It'd be 4 by 3x. That'd be 2 lots of 12x. And then the n term squared, 16. So we've got 9x squared plus 24x plus 16. Getting harder. Let's look at this one. First term squared plus twice the product. Oh, the product here is going to be neg 3 times 2a, or neg 6a, plus the second term squared is 9. So this is 4a squared, take 12a plus 9. Number's getting a bit bigger because we're sticking something in front of this front letter here. This one's 3y all squared. Can you do it without a bracket? Go straight to 3y by 3y is 9y squared. And twice the product, can we do it in our head? The product is 1 by 3y, it's 3y, but we've got 2 of them, so it's 6y. And the second term squared is 1 squared, which is just 1. Are you getting good enough to do this? Let's see, this is a biggie on the end, which we do. Try and do it without that middle line, so it's a first term squared. Now, the product, or we might need a calculator for this, is 7 times neg 3y. Remember, the neg 3 goes with that term. That's neg 21y, and we've got 2 lots of it. 2 times 21, neg 42y. Oh, that's a bit hard to do in your head. And then the second term squared, neg 3y squared, is 3y by 3y, 9y squared. So you can see, if you practice, you can actually get it in one line using, up here, remember, the perfect squared form. And we might just write that again now. It's a squared plus 2ab plus b squared, where a and b are standing for just numbers, or anything that's the first in the bracket is the A, and B is the second in the bracket. Lots to think about there, but gee, you've done well, all this work, and that's come to the end of the basic algebra that's usually done to the end of Year 10. I really want to congratulate you on doing such a good job, and I really want you to come back for the last presentation, which is going to try to say, why did I put you through all this pain, man? Cheers for now. See you in that final presentation.